In order to monitor where a shoreline is and where it will be going, we need to know what the position is at this current time. In order to measure that, we use Global Positioning System, or GPS, but the way these receivers work is they listen to signals coming from satellites that are orbiting the Earth. These signals have to go through the atmosphere, and they can get a little bit slowed down or messed up as they come through them, making your position a little bit off compared to what your actual position is. So one way to remedy this is we can use two different receivers. One is set at a known location, and then the other is what you're actually measuring. The one that is set at the known location can make corrections by measuring how far off the signal is and then correcting the other receiver. But in many cases, when we are surveying in a remote area, you need to generate this point yourself, and you can use the actual GPS receiver to record data over a long period of time, and it will see where all of the satellites were, what its calculated position was, and then compare that to other continuously operating reference stations in your area. So we have two different GPS receivers. They are actually exactly the same, but they can be set up differently to act differently. The base station will connect to the data receiver or data collector and via Bluetooth to send and receive data between the two of them. This is used for both setup, telling it needs to be a base station or it needs to be a rover for recording points, and it also will collect the data and record it for us. Similar to the base station, we have the rover receiver mounted on a 2-meter pole so we know its height, and we use it to actually record the points along the shoreline. It is receiving the corrections in real time from the base station. As we walk along the shore, we will place the bottom of the pole where we want to record the point, use the data recorder to record the point, and then we know exactly where the edge of the shoreline is. In this case, the shoreline is the base of the bluff where the actual erosion is occurring. So using the GPS receivers, we're able to record where the shoreline is looking from an aerial view. So we're looking in only the XY plane.
The purpose of recording the current location of the shoreline is not only to compare it to subsequent surveys, but also to compare it to historical locations of those shorelines. The way this data is collected is we use aerial imagery taken at some point in the past. We will line this up with the current base map. There's multiple ways to line this image up. You can rotate, scale, or move the image. To make the image line up more accurately, we add control points. Each of these control points are in the same location as the past, such as the corner of a road, the intersection of a road, the edge of a building, or anything that hasn't changed over time. Once all of these control points are added, we can zoom back out, splash the image back and forth between what's currently there and what it looked like in the past and see if everything lines up. Once the image is geo-referenced, we can zoom in and draw a line where the base of the bluff used to be. Now that we know where the previous shorelines were, we can use another program to cast transects across them and then measure how far they have moved over time. Using the linear regression that we calculated based on the previous shorelines, we can forecast with some uncertainty where the shoreline will be at a future date. In this case, it is projected out to the year 2030, and we can draw the shoreline for each based on the projection from each transect. Using the program to calculate the distances between shorelines, we can use that information to create a linear regression and estimate a rate of erosion that is occurring along each transect. So our position is being calculated by the Bad Elf GPS receiver, but we're using the iPod as a data collector, so we need to make sure that it's connected via Bluetooth. Once it is connected, we want to check to make sure that we are receiving data, so we open the Bad Elf app and make sure that it is connected and is showing our location and is seeing satellites. In this screen, we can see that the Bad Elf is detecting satellites and is using those to calculate our position. As shown in the Bad Elf app, the Bad Elf receiver will show how many satellites are available and if it's able to calculate its location. Using this position information, we can record where the current shoreline is using Avenza PDF maps. There are two different options for recording where the shoreline is. One is placing markers, which is in the bottom left-hand corner. The second option is to record a track as you walk along the bottom of the bluff or where the shoreline is. So using the map that has previous shorelines drawn on them, we can locate in the field exactly where those previous shorelines were.
We're looking to see how the beach changes as you move from the shoreline to the waterline. So to gather this information, we're going to use the Emery method, or two sticks in a string. And the way this works is you have two sticks of the exact same height, separated by a known distance using the string. In this case is 2 meters. And as we walk towards the beach, we can see the difference in the height of these two sticks by referencing the horizon to look towards the second stick with the other person and see what the height difference is between the two sticks. As we're walking towards the water, we want to make sure that we stay in a straight line and are always referencing back where we started. When we start all of this, we're using a compass to see what direction the transect is going to be pointing in, and we record that on our data sheet. So we need to measure the distance and height between the two sticks. We use the horizon as a sight level. So the first person upshore or towards the shoreline will take the first stick and move it to the same location as the second stick. The person with the second stick moves down towards the water and lines it up so that you're pointing towards the reference point again. And then the process is repeated. So when we record a beach profile, we like to get as much of the profile as possible. So we typically try to do this at low tide. As we're walking towards the water, we get to the edge of the water, but in most cases, we do not want to enter the water. So the aim is to make it perpendicular to the water, but in many cases, this can be difficult depending on where the water level is, just by sight. So we want to record the actual direction that we take this profile so that when we go back again, we can use the compass to go in the exact same direction for a repeated survey. So the purpose of gathering a beach profile is to have a data set that you can compare to in case of a storm event or in a case of a seasonal change. So when you record the points at different times of the year, you can see how the sand has moved and then the profile has changed. We can see which areas are experiencing erosion, and maybe some areas might be having accretion, so more sand is actually ending up on the beach. When you know this information, you can put in different mitigation tactics to prevent the erosion, or you can also do revetments or putting in a seawall or putting in some sort of barrier. There's also beach nourishment is an option to actually pump sand and put it on the beach. So the erosion is going to occur naturally. We're looking for larger changes. The beach is going to be changing every day. So depending on where the tide is, how active the currents were, and we're just looking for larger changes with this type of method.